So I was gonna say, I realized, like the usual model is for the person to come to lecture and to tell you new stuff, but it just doesn't work with this material. Like you got to practice. So I think using lecture time with this is good. Um, because I suspect the people who are not in lecture are thinking that they'll do the exercises eventually before the midterm. And I hope you do, talking to the camera. But also, like the plan is basically we'll do the exercises, we'll then have a lab that preps you for project one next week, and then you're going to be hopefully prepared to do project one, which is really what's going to prepare you for the midterm. So the midterm is going to be basically project one, which is to be posted, and the pointer exercises. Those are kind of at the core of what's in the midterm. So that's why we're doing that. Mhm. Yeah, I should say I made those exercises a while ago. Jenny Lofgren was not at the time teaching praxis. That's a coincidence. but, but anyway, I'll rename her to Evan or something. Not picking on anyone in particular. Right. So I'll give you a little bit of time to do to try to do a few of those, and then we'll do them together. Yeah, we're doing the exercises. So the people who just came in, we are doing the pointer exercises starting at Q20. I'm giving you a little bit of time, and then I'll do a few questions, and then we'll iterate from there. Did you see that? Feel like people were too busy doing the exercises to see that they did the Wonderland too. But okay. What? All right. Who did 22? Who is stuck? Nobody's saying anything. What are you guys doing? Okay. I feel like I don't see a lot of people writing solutions on the laptops, so I'll start. So we want to create an object of type student, and we want to have a car name and an int age. So doing it like this, and then we'll say, okay, so car name, and there's going to be 1,000 characters there, and there's going to be an int age, and that's going to be a student. So to initialize, we're going to say student S1, and you can initialize structs if you remember, like so. And that is going to be, okay. And I am set to say 41. Okay, so something like that. So initializing like this is allowed. You're not allowed to then say S1 is Bob 18. That is not a thing. So that's just strictly initialization. Make sense? So the next thing is we want to change the name from this to something else. So in the same way that you cannot do this with structs, you can only initialize it like this. You cannot do this with arrays, right? So we already saw it with arrays. So if you have an array that's like this, and you say 4, 5, 6, you are not then allowed to say 6, 7. All right, so that is just not a thing. So similarly, what's not a thing is s1.name is equal to Michael. Right? So s1.name is this guy in the same way that this is an array. You just cannot assign to arrays like this. Okay. So what can you do? Well, you can certainly do something like this. So this is changing the first letter of the name, and that's completely fine. You're saying in the same way that you can say something like array at 0 equals 6. That's completely fine. That's the normal thing. You can say s1.name at 0 equals to something new. That's the normal thing. Yeah. Yeah. It like depends on the version of C, I believe. So, but we are writing. I think you're right that sometimes it's allowed, but like we are writing it like that. So like the idea here is like the reason there is a repetition is that we're saying like type def this, and then we're saying like this, we're also calling it std. So we could call it something else as well, right? And people sometimes do. So that's kind of why the repetition is. It's not like I'm repeating student is I'm saying I happen to have decided that this struct is gonna be named student as well before it was called struct student.
Still use like struct student.
Yeah. Yeah. So people often, so I prefer to say student. People often say something like student T for type. Kind of maybe in part because they don't like the apparent repetition. It's not actually a repetition, right? It's more like I want to say if it's called struct student, and I want to be able to call it student for short. Right? So kind of the response to your question, like I believe in some versions of some languages, what you're proposing is allowed, but not all of them. But I'm not like 100%, so Google it. Yeah. I think that's new. I think it's like depends on the version of C, to my memory. Yeah. So okay. So okay, all right. So that is allowed. So yeah, by the way, another issue is that if you want a recursive structure, then that is probably going to create an issue. So if you want to use, so we'll see if you know about linked lists, or if you don't, I'll tell you later. So that is probably not going to work for you. So yeah. So okay. So that is allowed. You can, in principle, just change the Mike to Michael like this manually. Technically, the first two letters are fine. So you just say like s1.name. It would have been better if this were Michael in the first place, because that would be shorter. So you could say like s1.name is equal to hey, like so. And then like so, and then you got to make s1.name at 4 be a null, because if you don't, then we'll see actually in a second. So that's one way of doing it. So if I print s1.name like this, what I'll get is Mike. Cool. All right. What would be the output if I hadn't done this? Anyone? Like, would it work? First of all, who says it would work? Who says it would crash? No. Okay. No, you're wrong. It won't crash. Okay. Why wouldn't it crash? Yeah.
Because you already have the previous defined.
Yeah, exactly. So like all it does is it changes this to a K and it changes this to an E. That's fine. So now it's just gonna be like my name misspelled, right? So like one way of, so some people actually do spell it kind of like that. It's weird. So yeah, so this would be like the kind of like misspelling of how some people spell it in French, I guess, right? Yeah, so like usually like in France and in Starbucks, people spell it like this, I think, who had like the diaries. I think like, does anyone know French? I think like this with like a diaries is over here. So like you would think it's Michel, but like that's not the usual thing that people use in France anymore. So it's like Michael. So okay. So the people at Starbucks might not be experts in spelling, is another issue, but I believe that is actually the correct spelling. So okay. So One way of thinking about it is you just change this to KE, nothing else changed. So of course that's the output. Another way of thinking about it is the way you're printing s1.name is you're going to the address s1.name, and then you're printing this until you get to the null. There is a null there. So once you get to the null, you print the L and you're done. So if I don't comment this out, then what happens is it prints Mike. Why is that? Well, because this is KE, and then the A is replaced with a null. The way that the string is printed is you print every character until you encounter the null. Okay. So that is one way to solve it. The faster way to do it is to use a string function. So while I'm here, I'll include stdio so that it doesn't yell to me about printf, which it's fine with anyway, but yeah. So what I can do is I can say strcpy s1.name. It used to be Michael, and that would be Mike. So that's like this. So the way strcpy works is you send it the destination and the source. And what it does is it copies the source to the destination dest, including the null at the end of src. And it assumes that dest has enough space. So what does it mean that dest has enough space? It means that dest is an address, and you start writing at dest0, dest1, dest2, dest3, dest4, and so on. It assumes that there is enough space there so that you can store all of src, including the null. So you wrote a couple of string functions yesterday, and on Monday you did not write strcmp. We can write a version of strcmp now. So strcmp technically, strcpy, of course, technically returns a character. So what it returns is just the destination back again. So the signature is like this. So the reason there is a const there is like, it's not like you're supposed to modify src anyway. You're supposed to be writing to the dest. It's not a problem not to say const char star and to just say char star, but that's like the usual signature. Okay. How do we do it? Well, we just say so we just say, okay, so while src at I is not null, we copy from src to dest. So that's like easier than strcat, which you did in lecture, right? So in the lab, sorry. So you just say dest I is equal to src and you increment I. And then at the end, you also need to copy the null. So when you stop this loop, what's happened is src at I is a null exactly now. So you could just say one last time, dest at I is equal to src at I. Make sense? Questions about this? Okay. How many people are not 100% comfortable with this? Is this okay? Okay. So in the lab, I asked you a little bit to play around with pointer arithmetic. I'll give you kind of the annoying version of this with like annoying pointer arithmetic later. There is like a 3-line version of this that kind of works that people used to like to implement that uses pointer arithmetic, but that's basically what it is. So, okay. So that's like this. Let's go back. So change the age of the student. So that's easy. So unlike with S1.name, where we had to do strcpy, this is just nothing, right? So you just say S1.age is whatever, 40, and that's completely fine. So the way to think about it is you have this struct. You say S1.age, it's as if you're saying age over here. It's an integer. So you want to change it, you just change it. Like there's nothing complicated here. This is also the same, right? So S1.name works in exactly the same way that a character array would work if you define the character array in the function. So if I say something like car name, so I can say I want to copy something to name. I'll do letters so that it's like not ambiguous. Like that's exactly how it would work in the same way that this does. Make sense? Okay, questions so far? Okay. So, all right. So we want to create a pointer PS to the student and initialize it to the address of the student. So this would be student star. And this would be address of S1. So it works in the same way as everything else. Right? So in the same way that you can have an int star, you can have a student star. Yeah. So now what we want to do is change something. So this is initialized. So change the name of the student to something else. So I'll rename it to PS1. So how do you change the name using PS1? So one way to do it is to just say star PS1, like so. And that's the same as saying S1, right? That's how it works. PS1 is the address of S1, star PS1 back to S1. And then you can have .name again. You want to change the name, you do it exactly the same as before. Right? So all that we have is we have star PS1 instead of S1 because we initialized star PS1 to be the address of S1, saying star PS1 is the same as saying S1. This is not the usual way that people do it. This is like the logical way. But if you remember, there is a shorthand. So star A dot B is the same as A arrow B. So the usual way that people would do it, it's equivalent, but it kind of looks nicer, is this. All right. So the logic here is just that this is the same as S1. So same old, it's just that we have a pointer, we go back to the object. But because there is this syntactic sugar, where this kind of looks nicer, ordinarily you would do this. It actually, before it gets compiled, it just gets converted to this. All right, questions about this? Should be like completely logical, but at the same time, this is a very common pattern, right? So if you have a pointer, which you often do, you want to access an element, this is how you do it. Yeah.
And you go for address, like for straight, the address is the address of the first element. Like, let's try student, and why is that actually address?
Yeah. So the way to think about it is more. So that's a good question. But the way to think about it is more like this: if you have an int, and you have something like this, so what's the address of A? Well, that's where A is stored. In the same way, when you're asking what's the address of S1, it's like where S1 is stored, and then S1 is this compound data structure. So I think what you're saying, well, like the compound data structure, it kind of looks like it has the name first and then the age. So like, is it like the same as, where the first character of the name is? And the answer is like maybe, but maybe not. C gets to decide how exactly to arrange the subparts of the struct. So, and sometimes it will rearrange things for efficiency. So what that means is like you should think about it as just like one unit in memory that takes up several cells. You don't know exactly where what is. Okay. But you're right. So like let's do it just for fun. So let's print so let's try to print the pointers here. And again, like this is going to be different on different systems as well. So what I'm going to try to do is I'm going to try to print PS1. And I'm also going to print PS1 name. So this is asking, okay, like where is PS1 stored in the memory table, and where is PS1 name stored in the memory table? So let's see how that works out for us. Yeah, they are, in this instance, in the same place, right? The reason they're in the same place is the way S1 is stored, at least right now, is it stores the name first and then it stores the age. So the address of where S1 is the address of where the first character and name is. Does that make sense? Questions? So let me, this is going to be a live demo. I'm going to try to break it. Not guaranteed to work. Okay, that's still the same. Oh, I did break it. Oh, no, sorry. No. Okay, that's not surprising. Okay, if I figure out how to break it, I'll let you know. In principle, it can sometimes okay, that's interesting. So here it's stored just the one it stored the one character, and then it stored car name 1. Or so basically what I'm trying to do is I'm trying to make it more efficient for it to store the name first. Okay, I did not manage to break it. It's not guaranteed that the first element is going to be there, but I do not know how to break it right away. But again, that's like you cannot rely on it. So okay, so we were here. So we want to change the age. So to change the age, we just say PS1 age is equal to 40. You can also say star PS1 dot age equals to 40. That's the same thing. Does that make sense? All right. So we want to create the function that takes a pointer to a student and changes the name. So we'll call it change student name. It should take a pointer to the student, and then it should change it. So we'll say student star PS. And then what we'll do is we'll say, okay, if we have PS in the same way that we have PS down there, we can have a PS in here. It would be exactly the same. We'll just say strcpy PS name, and we change it to Mike. Right? So the logic here is in the same way that you operate on PS1 here, you'll operate on PS there. They're the same thing if you send PS1 to student change name. Does that make sense? Yeah. So with the structure as defined now, that is the only way that you can do it. So if you attempt to change the name without using a pointer, so this is of type student, so that has to be s.name, not s-arrow name. This would compile, however, it would not do anything. The reason it would not do anything is you have a local variable s, and then you're saying change the local variable s to something new. So you are using strcpy there, but in practice, what happens is you go and you change this local s, kind of the array inside it, you change it, but that's a local variable, it was copied. Does that make sense? So that would not work. We'll see that there is a subtlety there where if you change things just a little bit, it would be different. But right now, that is exactly what you expect, is S is a local variable. You change part of the local variable. You can think about it as like you send in an integer and then you change one of the digits in the integer. Okay, it's a local integer, you change one digit, fine. It was still a local variable. All right. So okay. So now we want to do the same with age. So change student age is the same. This is 40. Make sense? So let's recap. So when is it an arrow? When is it an S? One way to think about it is just if it's a pointer, it's an arrow. If it's not a pointer, it's a dot. Yeah.
You use like string.
Oh yeah. Sorry, that's silly. Sorry. Thank you. So it's a dot if it's a structure. It's an arrow if it's a pointer to a structure. Is one way to think about it. Certainly, if it's not a pointer, you cannot use an arrow because the arrow means the reference. So if it's not an address, it's not going to work. When you get into pointers to pointers to pointers, things become more difficult. But for now, that's the only thing. And then for now, with the structures that we have now, it's like you want to change the contents, you got to send in the address. If you send in the address, it's fine. You can change the contents. Make sense? All right. Questions about this? Like, anyone confused? No. Okay. All right. So now we want to call the function, and we want to use both kinds of things. So we already called ES1. So if we want to change student name but don't want to use ES1, we can also directly say at S1. And those are the same because we said PS1, which is a variable of type student star, is equal to address of S1. Okay. So this is kind of a combination of the stuff that we did yesterday and the stuff that we did right now. I do know that we just have 5 minutes, but please take the 3 minutes to try to do Q31. All right. So we want an array of 5 students. So how do we do an array? Same way. Like so. And now we want to change the element of index 2. So essentially change the name of S array at 2. So one way to do it is to say change student name. And then this expects an address of a student. So the address of a student is the address of S array at 2. Right? So that's kind of the most straightforward thing is you say, okay, like this is the address of a student. In the same way that you would say address of S1, you would say address of S array 2. The other way of doing it, and again, that's the same story as last time, is you can say S array plus 2. Like so, S array is the address of the first element. S array plus 2 is the address of the second element. The math works out that it's the same because, again, S array at 2 is actually star S array plus 2. Like that is literally what it means. And that means that the address of that is the address of star S array plus 2. And the address of cancels the star. Make sense? So it should make sense if you think about it. At the same time, if you're writing it, I think I would just write it like this, just by analogy with this. You would also see code like this just because this is kind of awkward to write. But I think this is clear. Again, mathematically, they're exactly the same. All right. I think we have 1 or 1.5 more lecture of pointer exercises. There will be a quiz on next Monday because I feel like attendance is going down. So gotcha. Yeah. So okay. All right. I'll see you. Bye.